As 1905 dawned, the soon-to-be 26-year-old Albert Einstein faced life as a failed academic. Most physicists of the time would have scoffed at the idea that this minor civil servant could have much to contribute to science. Yet within the following year, Einstein would publish not one, not two, not three, but four extraordinary papers, each on a different topic, that were destined to radically transform our understanding of the universe. The myth that Einstein had failed math is just that. He had mastered calculus on his own by the age of 15, and done well at both his Munich secondary school and at the Swiss Polytechnic, where he studied for a math and physics teaching diploma. But skipping classes to spend more time in the lab, and neglecting to show proper deference to his professors, had derailed his intended career path. Passed over even for a lab assistant position, he had to settle for a job at the Swiss Patent Office, obtained with the help of a friend's father. Working 6 days a week as a patent clerk, Einstein still managed to make some time for physics, discussing the latest work with a few close friends, and publishing a couple of minor papers. It came as a major surprise when in March 1905, he submitted a paper with a shocking hypothesis. Despite decades of evidence that light was a wave, Einstein proposed that it could in fact be a particle, showing that mysterious phenomena, such as the photoelectric effect, could be explained by his hypothesis. The idea was derided for years to come, but Einstein was simply 20 years ahead of his time. Wave-particle duality was slated to become a cornerstone of the quantum revolution. 2 months later, in May, Einstein submitted a second paper, this time tackling the centuries-old question of whether atoms actually exist. Though certain theories were built on the idea of invisible atoms, some prominent scientists still believed them to be a useful fiction rather than actual physical objects. But Einstein used an ingenious argument, showing that the behavior of small particles randomly moving around in a liquid, known as Brownian motion, could be precisely predicted by the collisions of millions of invisible atoms. Experiments soon confirmed Einstein's model, and atomic skeptics threw in the towel. The third paper came in June. For a long time, Einstein had been troubled by an inconsistency between two fundamental principles of physics. The well-established principle of relativity, going all the way back to Galileo, stated that absolute motion could not be defined. Yet electromagnetic theory, also well-established, asserted that absolute motion did exist. The discrepancy, and his inability to resolve it, left Einstein in what he described as a state of psychic tension. But one day in May, after he had mulled over the puzzle with his friend Michel Besso, the clouds parted. Einstein realized that the contradiction could be resolved if it was the speed of light that remained constant, regardless of reference frame, while both time and space were relative to the observer. It took Einstein only a few weeks to work out the details and formulate what came to be known as special relativity. The theory not only shattered our previous understanding of reality, but would also pave the way for technologies ranging from particle accelerators to the global positioning system. One might think that this was enough, but in September a fourth paper arrived as a by-the-way follow-up to the special relativity paper. Einstein had thought a little bit more about his theory and realized it also implied that mass and energy, one apparently solid and the other supposedly ethereal, were actually equivalent, and their relationship could be expressed in what was to become the most famous and consequential equation in history, E equals mc squared. Einstein would not become a world-famous icon for nearly another 15 years. It was only after his later general theory of relativity was confirmed in 1919 by measuring the bending of starlight during a solar eclipse that the press would turn him into a celebrity. But even if he had disappeared back into the patent office and accomplished nothing else after 1905, those four papers of his miracle year would have remained the gold standard of startling, unexpected genius.